Very good evening, dear students. Myself, Akhilesh Sharma, Assistant Professor at SIRTE Bhopal. Today's topic is types of flow. So, types of flow first is steady and unsteady flow. Steady flow is defined as that type of flow in which the fluid characteristics like velocity, pressure, density, etc. at a point don't change with respect to time. So we can say that del V upon del T is equal to 0 or del P upon del T equal to 0 or del rho upon del T is equal to 0 where V is velocity, P is pressure and rho is density of a fluid. Where X naught, Y naught, Z naught is a fixed point in fluid field. Unsteady flow is that type of flow in which the velocity, pressure or density at a point change with respect to time. Thus, mathematically we can say that for unsteady flow, del V upon del T is equal not to 0 and del P upon del T is equal not to 0. Second is uniform and non-uniform flow. Uniform flow is defined as that type of flow in which the velocity at any given time doesn't change with respect to time. That is length of direction of the flow. Mathematically, we can say that for uniform flow, del V upon del S is equal to 0 where time is constant, where del V is change of velocity and del S is the length of flow in the direction of S. Non-uniform flow is that type of flow in which the velocity at any given time changes with respect to space. Thus, mathematically, we can say that for non-uniform flow is del V upon del S is equal not to 0, where time is constant. Third is laminar flow and turbulent flow. Laminar flow is defined as that type of flow in which the fluid particles move along well-defined path or streamline, and all the streamlines are straight and parallel. Thus, the particle move in laminar or layers, gliding smoothly over the adjacent layer. Thus, this type of flow is also called streamline flow or viscous flow. Turbulent flow is that type of flow in which the fluid particles move in a zigzag way. Due to the movement of fluid particles in zigzag way, the eddies formation takes place which are responsible for high energy loss. For a pipe flow, the type of flow is determined by a non-dimensional number Vd upon nu called the Reynolds number, where d is diameter of pipe, v is the mean velocity of flow in pipe, and nu is kinematic viscosity of fluid. If the Reynolds number is less than 2000, the flow is called laminar. If the Reynolds number is more than 4000, it is called turbulent flow. And if the Reynolds number lies between 2000 to 4000, we can say that the flow is laminar or turbulent or transition flow. Next type of flow is compressible and incompressible flows. Compressible flow is that type of flow in which the density of the fluid changes with point to point, or in other words, the density is not constant for the fluid. Thus, mathematically, we can say that for compressible flow, density is not constant. It means densities vary at point to point. Incompressible flow is that type of flow in which the density is constant for the fluid flow. Liquids are generally incompressible while gases are compressible. Mathematically, you can say that for incompressible flow, rho is constant or density is constant. Next is rotational and irrotational flows. Rotational flow is that type of flow in which the fluid particles, while flowing along streamlines, also rotate about their own axis. And if the fluid particles, while flowing along streamlines, don't rotate about their own axis, then we can say that that type of flow is called irrotational flow. मीन्स आप क्लियर हो गया कि रोटेशनल फ्लो और इरोटेशनल फ्लो क्या होता है. तो ये कुछ टाइप्स ऑफ फ्लो है जो आज के लेक्चर में हमने देखा. नेक्स्ट लेक्चर में हम इनके एप्लीकेशंस या फिर हम आगे जो हमारे पास में जो और कंटिन्यूटी इक्वेशन है या बर्नौली इक्वेशन, यूलर इक्वेशन के बारे में हम स्टडी करेंगे. तो आज के लिए इतना ही. ठीक है. थैंक यू सो मच.